All right, Algebra 1. So this is what I wanted you to finish over the weekend, kind of keep our brain in the game, if you will. Took a quiz today, and it was okay. It's kind of hard stuff. I think we're, improving from when we first saw it, but at the same time, we got to give it a little more practice, a little more respect outside of class. So hopefully you're doing that, or you're probably not going to get much better at it. This is pretty difficult stuff. So we got to remember a few things. This idea right here, x to the third, or n to the third, that's cubic. And there's only one term here compared to like the next one's got 3 terms. So this would be a cubic monomial. So because the next one has 3 terms, we definitely want some form of trinomial, but the very largest power here, the one in the very front, is quadratic, not cubic. And so this one down here, number 6, this is considered a linear binomial. It's linear because it's just x to the first power, and there's 2 of them. That's making the idea of the binomial. So we did this one in class today, just kind of getting ready for the quiz. And so when you're adding, notice that the signs don't change. For example, if I'm looking at this one that we've already talked about, this is 1a to the 4th plus 7a to the 4th, 8a to the 4th. Those aren't changing powers when you add or subtract, really. Same thing here, negative 5a to the 3rd plus 8a to the 3rd. It's kind of hard to read, but this right here is to the 3rd. And then the last one, 5a and 6a, 11a. So they're not changing when you add or subtract. Let's do one that's subtraction from the very beginning. And I knew this was going to be difficult for a lot of us, especially when we've only seen it just a little bit. And if you don't practice a lot outside of your classroom, it's going to be challenging. So this is really subtracting everything in here in the second parenthesis. So you got to really know, just change all the signs. So then you go to put stuff together. 8x to the 3rd minus 6x to the 3rd, 2x to the 3rd. 5x squared plus 5x squared, that's now 10x squared. Negative 4 plus 4, 0. So I can just stop right here. Green light, done. So knowing to put the ones together based on like terms, when the powers are the same, put them together. Don't change the power if you add or subtract, and try to put it in descending order where it starts with the highest power, goes to the lowest. So I saw several people still struggling with this, and I know that if this is something you struggle with, then the back's almost impossible because it's like multiplication and division. They're backwards of each other. They're reverse operations of each other. So if you struggle with multiplication, division is going to really be difficult. So let's go back to the way I originally presented this. You are distributing that 4k to 7k minus 3, and then when you're done, you're going to distribute negative 5 to 7k minus 3. So you should have 4 numbers. And the first time you multiply, you're going to have k times k. So 4k times 7k, 28k squared. Because you have 2 k's multiplying. That's what exponents represent. How many of those numbers are multiplying? There's 2 multiplying in that step. So let's multiply again. 4 times negative 3 is negative 12, but there's a k on it. I'm seeing some people leave off the variables when you do this on the quiz. That'd be negative 35k. And then the last one, negative 5 times negative 3, positive 15. Excuse me. So let's combine like terms, and the front doesn't change. These change to negative 47k plus 15. So I'm just making it look as nice as possible so that everybody can see at home what the answer is. And this is the final answer. It's a quadratic trinomial. Quadratic because it's k squared. Trinomial because there's 3 numbers here. So GCF, just to do one again, kind of talking about number 16. 5, 20, and 30 are all divisible by this 5. So I'm dividing to see that there's a 1 here, and a negative 4, and a negative 6. But then when it comes to the exponents, you want to go for the lowest one possible. So 3, 2, 1, let's take that 1 out front. And that reduces all the powers by 1. So instead of 3, it's 2. Instead of 2, it's 1. Instead of 1, it's none. So doing the method can be a little challenging. So I want to start by looking at number 19 and kind of explore that with you guys doing the method. So this is 5 times negative 7, negative 35. So you're trying to multiply to be negative 35. But when you add together, these values that you come up with should be 2. And so I'm thinking about 7 times 5. But to get to 2, you probably want 7 plus negative 5, and that's how they would give you both values when they multiply and add. So I'm going to go back in and basically separate the middle term using the 7 and the negative 5. I'm going to put an n on it so that if I wanted to put it back, it would still be 2n. I don't really want to do that because I'm trying to factor it. So I'm going to take out an n, get 5n plus 7, take out a negative 1, and you get 5n minus 7, plus 7, sorry. So once you do that, 5n plus 7 is one of your answers. And then what you took out, this n minus 1, that's the other part. So this one's A. Now, on number 20, this one's a little easier because there's a 1 here. When you multiply, you really just need to come up with the two numbers, and then we can kind of put them in the answer because the only thing that's going to give you v squared in the front is something like v times v. C doesn't really make sense because they don't all have v in common, and if you distributed that, you'd only have a binomial, not a trinomial, so that's not what we want. So it has to multiply to be negative 80, but when you add them together, you get negative 10. I'm thinking negative 10 times 8, because if you did that, that would give you negative 80, but if you add them together, you get negative 2. And that's what's leading me to think about D as an answer. Negative 10 and positive 8 as the factors. Three more real quick. This is called a difference in perfect squares because they've added to be 0. The C value in the middle is kind of gone. So the only thing that's going to multiply to be n squared is having an n in both positions. And then let's do a plus and a minus. 9. Oh, no. Sorry, messed that up. Didn't do that right. Plus or minus 3. Because those multiply to be 9. 3 times negative 3 is negative 9. They add to be nothing. So that's what we want. So this one, we're trying to multiply to be negative 30 while adding to be a negative 1 in the middle. So that's going to be m minus 6, m plus 5. Okay, so one more. Let's go through that method. 7 times negative 12 is negative 84. And what would multiply to be that? But if you add it together, you get 25. So really not sure. I'm going to have to grab a calculator and kind of think about it for a minute. And when I think about this, I'm going to use division to see what numbers give me, 84. So I take 84 and divide by 4 and you get 21. And that feels good, but if you think about it, if they have to add to be 25, that means they'd have to both be positive, and that doesn't multiply to be 84. So let's try 84 divided by 3, and you get 28. Now this is better because that means that 3 times 28 is 84. And if you think about it, 28 minus 3 is 5. So this is what we want. 28 times a negative 3, 28 plus a negative 3. So now we're going to go in here and we're going to break up the middle. Instead of 25, we're using 28 and negative 3k. And then I'm going to use that idea of group factoring. So 7 and 28 have 7 in common. You're left with k plus 4. Take out a negative 3, you get k plus 4 again. And so this is going to be our answer because we have a repeated factor. That means that 7k minus 3 has the idea of k plus 4 in common. So please look over this. Come in next week on our Monday, Tuesday short week. We're going to be able to practice some of these ideas, make sure they're still there in your mind when we come back from Thanksgiving, because that's when we're going to take a test over this. So good luck. Thanks for watching the video. Have a good weekend.